Okay.
So the problem is when there's 22 of them, sometimes I miss a lot of things they say
Right.
because it goes,
That's what I was going to ask. How do you see all that if you miss it?
if they, like they're all meeting up. So concurrent would be when 1, 2, 3 or more lines all intersect at one point. That's what concurrent means. Yeah. Okay, I'm going to go to the next slide. And then we have even one more slide because it was that long of a homework. Are there any that you know you want me to go over yet? Snowflake. Oh, they called that a snowflake. 13, 12. Okay, yep. Go over 12, 13. I'm just not going to look at that tab because I don't think they're ever talking to me when they're talking to each other. What else? Yes, I can read the. These pictures were not as hard to draw as the other night when we had all those pictures, huh? These should have been much easier. Sometimes, always, sometimes, always, always, always. No nevers. There were no nevers in that section. Watkins, your school needs one camera. You don't each need a camera, but your school needs one. If you ever want to have a partner on a quiz or an assessment, you would need a camera. One more page. Let's start with number 12. Okay, so remember, anything I open up here is going to show up there. So that's good. Okay, number 12. KM, with nothing on top, naked KM, represents the length of a segment. So we've talked about the difference. We spent a whole, spent a whole slide talking about notation, about the difference between A and B. So A means the distance from K to M. It is a length. It is a number, like 5 inches. B is segment KM. That is an object, like a triangle. You can't give it a number. You can't assign it a number because it's an object. So that's why 12 would be true, because KM, since I didn't put a symbol on top of it, it's not a segment. It's a length. It's a number. Okay? 13. 2 lines are parallel if they don't intersect. We're going to kind of get into that later today, the if-then type thing. So all we know is that they're not going to intersect. If they don't intersect, do they have to be parallel, or do they have another option? Don't forget about skew. Yeah. So they don't have to be parallel if they don't intersect. So that's why that one is false. 2 lines are parallel or skew if they don't intersect. See the difference? Okay. Next one you asked about, example, and then 34. Okay. Do you write on top of it, or do you capture it? Yeah. Okay, we're going to have a quiz like this way further in the year, but where you're having to decide which quantity is larger, okay? So if the quantity, well, let's just talk about each column. The number of lines that can be drawn through 2 points. One of our postulates says, through any 2 points, there's exactly one. Who's going to say it first? Yes, line. Very good, Victor. Through any 2 points, there's exactly one line. So the value of column A is 1. That is the value of column A. Column B, the number of planes that can be drawn through 3 non-collinear points. I have 3 non-collinear points. How many planes can I draw through those 3 points? Also 1. So the value of column A is 1. The value of column B is 1. So we would say that C would be the answer. The 2 quantities are equal. Ready? Last one. Always, sometimes, never. We did this in our practice yesterday, I think. How many lines, or the day before? How many lines contain point B? And you get it now. Okay. The answer is infinite. Yeah. Oh, 34. Sorry. You're right. Thank you, Ms. Johnson. Well, now you know what the answer to 24 is. Okay, but you said you get it now. 3 points. Okay, the key word in this entire sentence is determine. It's not asking if they're coplanar. It asks if they determine a plane. So that's when you picture that tripod and you put all 3 legs in a row, and what happens? Boom, the tripod falls over. So 3 points sometimes determine a plane because the stipulation is they have to be non-collinear. As soon as they're collinear, that plane is not unique anymore. That tripod just fell over. Okay. Whoa, way too much talking. What do you think of when you hear inductive and deductive? Just what comes to mind? Inside and outside? Have you heard these words before? Mystery, yeah, me too. I think of like Sherlock Holmes. Oh my goodness! Me and Lars are on the same page. Lars and I, sorry. Okay. So it's when you're figuring something out, right? Okay. So inductive reasoning is when you are predicting something about the future, predicting something that will happen in an experiment. It's a hypothesis. So when you are using inductive reasoning, it is a hypothesis or a conjecture, and you are predicting what is to come. Have you done that in your science classes yet? Have you had a lab where you're having to predict the outcome and then you test it out? Good. So when you are in science and you are making a hypothesis, you are using inductive reasoning. Adriel hasn't yet. Okay. Well, you will. Conversely, deductive reasoning is when you have a series of facts and you come to a conclusion. So the key word on this one is conclusion. The key word on inductive is prediction, and a key word on deductive is conclusion. Okay? You are following a sequence of facts and you come to a logical conclusion. Hypothesis is inductive, yes. Okay, so when you are reasoning through something, first you look for a pattern. Is something happening the same every time? Then you make a hypothesis or a conjecture. Those are pretty much interchangeable for our purposes. And then you make sure you verify it. You test it out. You do the lab, whatever you're working on, okay? So let's see if we can tell the difference between inductive and deductive. I'm going to give you a situation, and you're going to decide whether you think it's inductive or deductive. It's indisputable. It is a fact. We're not wondering. It's a fact that he is old enough to vote in the United States, so that's why that one would be deductive. Okay? It's a valid argument. Good. It is a valid argument. Okay. Don't find the next step in the pattern, but tell me whether this is inductive or deductive. And I wish you couldn't see the answers, but you can. Vote what you really think it is. And you don't have to type it in the chat because we have the poll over here to the right, so go ahead and type it in the poll. So we are predicting what comes next in a pattern. When you're predicting, when you're filling in the blank, then it is inductive. That is inductive reasoning. Predicting what comes next. Inductive. Okay, next one. Jonah is taller than Emily and Kate is shorter than Emily. Who is taller, Jonah or Kate? Katie. I don't care who's taller. I just want to know if it's inductive or deductive. So change your answer if you need to change your answer in the poll. Would you solving this answer be inductive reasoning or deductive reasoning? Are you hypothesizing or are you concluding? Ooh, this one's closer. 63%, someone clicked broadcast results. 63, oh, now it's getting higher on deductive. Are you wondering who's taller, or can you for sure conclude who's taller? You're right. Most of you are right. You can for sure conclude. So that is the conclusion. It's deductive. We're not wondering, we're sure. Look, see, there's 3 kids measuring who's taller. A vintage picture. The sun has risen every day of my life, so the sun will rise tomorrow. I'll start the poll again. Okay, there, it's cleared. The sun has risen every day of my life, so the sun will rise tomorrow. Can't mess with science. Are you concluding or predicting, though? I know it's probably going to rise tomorrow. I agree. It's probably 99.9% chance that it's going to rise, but there's no certainty, and we are predicting something that hasn't happened yet, so that is inductive, even though it's probably going to happen. It is inductive. Very good. Y'all are too good. You know what? We're just going to move on because y'all know what you're doing. We're going to watch a quick commercial from DirecTV. So the audio might not have been the best. If you want to watch it yourself, you can Google or go to YouTube and look for the DirecTV commercial. The point of that was that that was a logical reasoning sequence, and that's what we're studying today. So if you get bored, then you'll start staring out the window. If you stare at the window, then you'll see things you shouldn't see. Blah, blah, blah. Then you'll attend your own funeral as a guy named Phil Shifley or whatever, right? Okay, so all of those sentences that they were using in that commercial were called conditionals. You should have these notes. They should have been printed for you, or you should have printed them. They're like a little half sheet of notes with the cartoon on them. So you should not be writing any of this down. You should get to just watch because these were printed for you. It's coding stuff. Do you like to code? Is that one of your hobbies? All right, so a conditional is an if-then statement. If you use your cell phone in class, then it will be taken away. Doesn't work very well for you guys because I can't tell if you're using your cell phone or not, but we use the honor system, right? Okay, so every conditional has two parts. This is also going to sound like science. The part after the if is the hypothesis, and the part after the then is the conclusion. The lady behind you can see if you're using your cell phone. All right, so you use your cell phone in class is the hypothesis, and it will be taken away is the conclusion. Two parts, the part after the if and the part after the then. Do you want us to tape the notes to a notebook or something? Oh, that's totally your decision where you put them, but it has a front and a back. I don't know how they printed it out for you. But yes, I would keep these notes where you keep all your other notes. If I do my homework, then I'll get good grades. If I get good grades, you'll send me to college. If I go to college, I'll graduate and get a job. If I get a job, I might get fired. If I get fired, I could go bankrupt and lose everything. And that's why I didn't do my homework. Do you ever tell your parents that? True, true. Another example of if-then statements. Yeah, it's cute. Okay. Converse. I'm going to throw a lot of words at you, and I'm going to expect you to go home over the weekend and look at these a little bit more because I'm going to go quickly, okay? Converse is another C word. We have lots of C words. Conditional, converse. I'll give you some more in a minute. Contrapositive, counterexample. A converse, when you hear that, yeah, shoes. I want you to think reverse because they almost kind of rhyme. Converse, reverse. Converse, reverse. When you're doing the converse of a sentence, you are switching, like Parent Trap, switching the hypothesis and conclusion. Okay? So, if your cell phone is taken away, then you were using your cell phone in class. If you attend your own funeral as a guy named Phil Shifley, then you were looking out your window. So you're switching the hypothesis and the conclusion. That's converse. Negation. What do you think of when you hear negate? Negation. Not. Good. Maybe you looked at the board, or maybe you already thought that. Subtract, not, nil. Okay, good. So when we negate something, we, just like you said, we literally just put the word not. Now, what if something already has the word not? Like, how would you negate the word non-coplanar? Negate that. Very good. So a double negative, kind of like a double negative, turns into a positive. So if you do come upon a not sentence and you want to negate it, then the not-nots kind of cancel out, and it becomes a yes or a do. Okay. Oh, yeah. Okay. Inverse, like I said, throwing a lot of words at you. An inverse is when you take the hypothesis and you put not, and you take the conclusion and you put not. If you do not use your cell phone in class, then it will not get taken away. If you do not stare out the window waiting for the cable guy, then you will not attend your own funeral as a guy named Phil Shifley. Math is being grammatically incorrect? No, we're not. What is neg? What is negation? Is that what you're asking? It's when you put the word not, we just negated the sentence. If you use your cell phone in class, The negation is if you do not use your cell phone in class. You just add this word right here. Okay? This is all in your notes, so I'm not going to stay here any longer. Okay, here's the trickiest one of them all. Contrapositive. It does double duty. It's like working two jobs. The contrapositive is going to make the hypothesis and conclusion switch places, and it's going to negate both of them. So it's like a converse and an inverse all wrapped up into one. If you use your cell phone in class, then it will get taken away. If your cell phone was not taken away, then you did not use your cell phone in class. Is that okay with everyone? We're going to practice. Okay. Grrr. Okay, it's a lot, I know. Okay, let's practice with the one from the commercial, because that's more fun than my cell phone example. If you wait for the cable guy, then you get bored. I want everyone to find somewhere and write the converse of that statement. If you get bored, then you're waiting for the cable guy. Go ahead and try the inverse. Don't type it in the chat, just write it on your sheet of paper. Try the inverse. That's when you negate the hypothesis and the conclusion. Oh, sorry, we're doing the inverse of the original. You were probably wondering. The inverse of this first one of the conditional right here. The inverse of this. I think that's what I did, of the original. Yeah. Ready? Inverse means you put not. If you do not wait for the cable guy, then you do not get bored. Did you get it right? Thumbs up? Someone's trying to talk. Turn it off, Watkins. Turn it off. I can tell now who it is. Stop! Doing the original again. Switch places and negate the original. Oops, sorry. All right. If you wait for the cable guy, then you get bored. If you are not bored, then you are not waiting for the cable guy. What questions can I answer about these new words that we just learned? Probably nothing until you start your homework, huh? It's actually my favorite part is counterexample, but every sentence has a truth value. And if you've ever, because some of you research math for fun, if you've ever researched doing proofs or proving something, you've learned that if you want to prove something true, you have to show that every time the hypothesis is true, the conclusion is also true. That's not easy to do. If you want to show that something is false, and I know this is hard to see because it's yellow, if you want to prove that something is false, you're in luck, because you only have to find one time when the conditional is false, and then the whole sentence is false. One case. One case. So if you can find even one time, one example that disproves your statement, then your statement has a truth value of false. So it's way easier to prove things false than it is to prove things true. So we are going to learn how to look for counterexamples. A counterexample is when you prove a conditional false. When you are trying to find a good counterexample, you need to make sure that the hypothesis is still true, but the conclusion is false. You want to lead people on and think it's going to be true, and then wham, hit them with it. Nope, sorry, it's not really true. False. So you want the beginning to be true, and the end to be false. So if you use your cell phone in class, then it will get taken away. Who has ever used their cell phone in class and it didn't get taken away? I'm sure that you guys have ways that you can very slyly look at your cell phone and we don't see, because believe it or not, we don't have eyes in the back of our head. So if that has happened before, then this statement has a truth value of false. You found a counterexample all day, every day. Oh no, don't tell me that. I don't have a phone. That's good. Good for you. All right, let's practice with one. I'm going to be lazy. If today is not a weekday, then it is Saturday. Here's the hypothesis. Here's the conclusion, because I think y'all are okay with that, okay? So we're not going to spend a lot of time on that. What I do want to focus on is the truth value in the counterexample. Good! Y'all are doing good. Yeah, they pop up, yeah. The truth value means I want you to tell me if that statement is true or false. Remember, if you can't think of any time when it's ever false, you put true. But if you can think of even one time that it's false, you put false. So y'all are saying the correct things. The truth value of this sentence is false because I know of a counterexample. And what is the counterexample? It's just one word. What is it? Sunday, Sunday, Sunday. Okay, Sunday. I forgot that. Okay. So a counterexample most of the time is one word or one phrase. A counterexample is not a sentence. It's the only one of these that is not a full sentence with an if and a then. It's a word. Meh? You still don't get it? Well, then let's do more. All right. Are you a counterexample? So I'm going to reveal a sentence, and I want you to decide if you are a counterexample. Remember, a counterexample makes the beginning true and the end false. Do I need to go back to the other one? Let's keep doing this and let me know if you still have trouble. Okay. If you are a Texan, then you were born in Houston. Who is a no, don't say true or false yet. I just want to know if you are a counterexample. So you would want the beginning to be true. If you're a Texan, that would mean you're technically born in Texas, unless you're adopted Texan. So that would mean you're born in Texas, but you are not born in Houston. So what would be some examples? Why do we need this for math? Because it's logical reasoning. You're reasoning through things. I'm teaching you how to argue. Teaching you how to argue. If you were born in California, would you be a counterexample? No, because you make the beginning false and the end false. That's not a counterexample. Counterexample is when the first part's true and the second part is false. So someone born in Dallas, someone born in San Antonio, someone born in Austin, those would be counterexamples. Okay? Okay. Next one. If you are a girl, then you have blonde hair. Is anyone in my second period a counterexample to that? You are, Chloe? Who else is a counterexample to that? If you're a boy, you're right. You should not be a counterexample. Anna, do you have blonde hair? You need to be a girl. That needs to be true, but you need to not have blonde hair. So you need to be a girl with brown hair, black hair, or red hair. Or strawberry blonde, whatever you want to call it. Okay. Let's try another one. Let's keep going. If you play video games, then you have an Xbox. Who is a counterexample? You are, Idril? Okay. So that means you do play video games, check. But you don't play them on an Xbox. You play them on the PS4, you play them on the Wii, right? Or you play them on the computer or a PS3. But if you also have an Xbox too, then you're not a counterexample. Wii U. Okay. Last one. Don't make me cry. Yeah, it's because the poll. You're right. If you're in geometry K/H, then you love math. Who is a counterexample to that?